Welcome back, everybody. Yesterday, we finished the terminal. Today is going to be day two of Foundations of Programming, and we're going to pick up from where we left off yesterday. This was the last slide that we had covered. We talked about terminal commands, and then we broke off for the last hour of class where we focused on nothing but the install fest. So we did finish a little bit early, but what that allows us to do is make sure that everyone was on the same playing field moving forward. Uh, I don't know if I covered this part about the terminal, but you are able to customize it if that's what makes your heart happy. Right. So you can customize it. You can right click your terminal, and I believe you can go to settings. Um, Give me a second. Uh, you should be able to right click, or where is that? Pretty sure right click, color, custom, or you can probably come down here. Yep, you press the down arrow. You can open up settings if you're on Windows, and you can set up stuff, right? You can set your default terminal to what you want it to be. You can even go to color schemes and stuff like that, and mess around with your stuff. There's tutorials how to do this if that's what you would like to do. I don't care for too much for this, but some people like it because it makes things easier to read. So I do want to make sure I did voice that this is available for you. All right. But without further ado, let's go ahead and get into Git. Before I actually go into the slide, Git and GitHub. Uh, who can tell me the difference between Git and GitHub, or what is either one of these? Anyone have their own explanation of what it might be?
Version control.
Version control. That's the best straightforward answer I could have gotten. Absolutely, version control, right? So there's a difference between Git and GitHub, but essentially, the overall top level concept of stuff like GitHub is that it is a form of version control, right? So what you're able to do is, let's say I want to start a new project. I'm going to build the most basic app that everyone starts off with. I'm going to build a calculator app or a to-do list or something that generic, right? What happened would be is, let's say I'm working on this project with Dominic, right? And Dominic wants to be able to have access to my project and make updates or make improvements, uh, or work on this project at the same time as I do. So we need some kind of platform where we can both collaborate and at the same time, and probably the most important part about GitHub or version controls in general is the fact that you're able to control the version of your project that you are working with, right? So which could prevent you from accidentally deleting something or breaking your program by accident, right? It allows you to make updates and improvements to your existing project without affecting the original, right? So the best way I like to think about it is kind of like you essentially make a copy of your project, you work on your copy, and then once it's good to go and you know it's working, you make this the most updated version of your original project, right? And that's kind of what this branch or this diagram here is showing you. That Git is a local, and I'll specify it on local right now. It's a version control system that is used to track changes to a file or files. And you're gonna see this diagram pretty often when talking about Git and GitHub. Uh, to explain to you what you're seeing, the green dots, right? This line represents a timeline, right? This timeline is the timeline of your project from start to finish. Um, every single one of these blocks kind of represents something big, like a feature or something about your project where you did some kind of updating on your project, you added something new or changed something, or so on and so forth. A different version of your project, right? Um, and then you have these what we call branches, where you are able to branch off from the current state of your project and work on separate features or separate functions or separate pieces of the work where you are not affecting your original project, but you're able to copy your original project, work on it in a safe environment where you're not going to mess up what's already working. And then once you are ready to actually update your project, what we do is we merge these branches back into our main branch, right? And you're gonna hear that different terminology, your master branch or your main branch. That just it's referring to the main version of your actual project itself. You can also see here that there's two different branches, right? There's one that represents my work, and then what another one that represents somebody else's work. So we're able to both collaborate on the same project, either me and Dominic or me and like 10 others or for however many people I decide to bring in on this project, right? So that's what Git and GitHub is. It's a form of version control. Do I have any questions before I move on into the differences between Git and GitHub?
I've heard a lot about like continuous integration, continuous deployment. Is that what the GitHub is about? It's version control?
Not necessarily. You don't have to deploy anything or continuously deploy stuff. That goes into a much deeper concept. This is in layman terms. One thing we're focused on is surface level. The fact that what GitHub is, it's essentially a server somewhere that you're able to store your project. Someone can copy it and work on it at the same time as you can. You don't have to, it can be used for continuous deployment improvements, absolutely. But that's not what it really is for, or specifically that's its main function. Does that make sense? It's not its main function.
Okay, makes sense.
The main function is just the overall concept that you're able to create different versions of your project and collaborate with others. But yes, it can be used for that. So Git, what is Git and what is GitHub? So Git and GitHub are actually not the same thing, right? Let's talk about GitHub first. So GitHub, as you've already experienced, for those of you who have been in guided application, or as you know, if you've for those of you who've used it already, because you've already used install fiz, you've copied down the repository down to your computer. GitHub is essentially some server somewhere. Think of it like the cloud where you can host your repositories. You can keep your folders, your directories, or your quote unquote repo of your actual project. It's somewhere where you can store your original project, and instead of keeping the main project on your computer, you can send it up to GitHub, and GitHub will hold it for you. And from GitHub, you can have other people collaborate with you, where they can bring it down to their computer, work on it there, and then send it back to GitHub. So it's kind of like the center point of where all these different things come together. So if you're collaborating with other people, it will stay on GitHub, right? They hold it for you, and then you can bring it down or send the updates up there, and they just essentially keep track of it, right? Git is a little different. Git refers more to your local version control. This is actually referring to your actual computer, right? So when you bring something down from GitHub onto your computer, you're essentially using Git, right? That's not necessarily GitHub. Git allows you to create a copy or to bring something down from GitHub and have it on your computer and work on it. For example, kind of like how you guys cloned the curriculum, right? You guys use Git clone and you copy the curriculum from the Foundations of Programming repository, and you cloned it down to your local version control system here on your computer, right? If you decide to make updates to it, if you create new folders, if you change stuff, if you delete stuff, it's not going to impact uh, what's on GitHub, right? It's only local in your computer. It's just there, right? So it won't affect anything. Now, you are able to connect your Git and your GitHub together so you can send updates back and forth. And we'll get into that in a little bit. But essentially, Git is the local version control on your computer, and GitHub is the version control on actual GitHub. That's the easy way of explaining it.
Another follow-up question to that then.
Yes.
So let's say GitHub does not exist. What does Git do if that does not exist?
That's not necessarily a thing. It's kind of like saying, how does the chicken exist but not the egg, right? Or not the egg or not the chicken.
Yeah, so I was wondering then, if they're not the same thing, does one go from the other? Like one rely on another?
Think of it like this. You guys have Dropbox? Yeah, have you ever heard of Dropbox,
Yeah.
Andy?
Yeah.
right? Or like your cloud storage. It's kind of like that, right? Cloud storage in this essence is our GitHub, right? Your documents, right? Your local storage of your computer, uh, your SSD. That's what's holding your local stuff, right? It's the storage on your computer is your Git. The storage on GitHub, that's um, that's in the cloud somewhere, right? Somewhere has it in their in some server. So just two different things. Really, it's where stuff is being stored at, right? So Git is being stored in your computer. GitHub is the actual GitHub company. Does that make sense?
Does Git stand for something to make it
Uh,
better?
it does stand for something. I do not know the actual acronym off the top of my head. Let me look it up. What does Git or GitHub? It's something dumb, I think, if I remember correctly. It's something global information tracker. Never mind. I thought it was something dumb. I could have sworn it was something dumb. Yeah, global information tracker. um, it's just how they differentiate the naming of Git and GitHub are just so you can be able to talk, in technical terms about two different things. Does that make sense?
Yeah, it makes sense. Thank you.
Don't get too confused with Git. It's just referring to your computer tracking uh the progress. As a matter of fact, let me show you. I'm gonna show you an example, a real life example that I was working on. Um, I was working on this earlier. So I was working on the intro to coding self paced where I'm creating new problems for our curriculum. Right. This should be done within the next month. But let me open up on VS Code, and then let me open up. Can I go? I think I can do here. GitHub intro self paced. So here is GitHub, right? GitHub holds a copy of the intro to coding self-paced, right? As you can see, I have a copy of the current project that I'm working on right now. I have module one and module two. It's not much, right? But it's here, right? Now I also have the exact same thing on my computer, right? On the storage in my computer. I opened it up from my computer. Here's the intro to self-paced, and here's the modules that I'm working on, right? Module one, and so on and so forth. I can make updates to these, right? And it won't impact what's on GitHub because in GitHub, where this is stored at is on their own server somewhere, right? But this copy of the intro to coding self-paced is on my computer. Now, how you connect these, we're gonna see in a little bit, but I can do git status, and I don't know why my computer's lagging. Git status. Okay. Um, I'm in the wrong area. Okay, there we go. My computer is lagging. What the heck? Git status. I'm so sorry. I don't know what is going on with my computer. There we go. I did get status, and it tells me that I'm on branch main. Your branch is up to date with the origin main. This is referring to GitHub, right? It's saying that the version that I have here on my computer is up to date with the version that's on GitHub. So I have it connected right now. We're going to talk about how we're going to do this, but it's able to track the version between what's on my computer and the version that's on GitHub, right? And then I also have some stuff here that I have not committed, and we'll talk about what that means in a little bit. But it's saying that there's 4 files here that I've made changes to that have not been updated on GitHub, right? No changes added to commit, and we'll talk about these in a little bit. But notice that I use git status, right? Why did I use git status here? Well, what happens is when you clone a repository from GitHub, or you decide to start a version control on your computer, what you're going to do is you're going to type in a command called git init. And what that's going to do is going to create a folder, a GitHub or a Git folder on your computer. It's hidden, I believe. They naturally hit it so you don't delete it or mess with it. But it starts a folder that keeps snapshots of everything that you do. So if I go in here and I make a space, right? If I put a space here or a new line, this folder has now changed, right? And it's going to take a snapshot of that. It takes snapshots of everything that I do, and it saves these snapshots on a folder. And when I'm ready to make these changes onto GitHub, what it's going to do is going to take the snapshots from this folder. It's going to use that to update what's on GitHub. So Git, right, is the local repository that's being what's keeping track of the changes of your project on your computer. And then GitHub is the version control up here. So two different concepts. Does that make sense, Andy?
Yeah, it makes sense.
I
You
feel
gave
like
me a
that.
lot more than what I asked for.
Yeah, it'll make sense a little bit more once we start talking about it more in depth and actually go into the commands. But this is a real example of me working with GitHub and updating our repository on here. But all right, let's go ahead and continue and see if it makes a little bit more sense as we go through the class. So why do we use Git, right? Um, Before we had GitHub or Git or some form of version control. It made it very difficult to make changes to stuff, right? For those of you who are a little bit older, right? I'm talking like my age or a little bit or older. Uh, when you're working on essays, right, in elementary school or middle school, and you were in the computer in the library and you're working on your school paper, right? Let's say you're making great progress, you're three-fourths of the way down. How were you able to open that up at home? Let's say you made most of the work here, but now the library's about to close. You have to leave. Unfortunately, you haven't finished your project. Uh, so how would you open it up at home? Well, before we would have to save it somewhere, right? You would save it on your computer or on a USB or a floppy disk, depending how how ancient you may be. And then you brought that back home and then open it up from there, right? Or what also might happen is, let's say you were writing once again an essay, but you had to proofread it and make adjustments. So you would make version one, right? You would make like, my essay number one. And then you realize that you need to make changes to it. So you would make a copy of it, but you didn't want to remove the last one. So you would make a copy and then work on the new one, like my version number two. And then you would make like, final draft or final version or whatever. And somehow you always end up making another version because you messed it up or you have to go back and fix it. It removes this issue, right? Version control, like GitHub, version control system like GitHub allows you to be able to work on a project and make updates or different versions of it to create features without actually impacting your original and also being able to work from anywhere, right? So Git solves these problems. It provides safe points and possible backups of your code should you need them. And it's going to happen, right? It's going to happen when you guys get into the Mercer program, when you're working on your personal projects or your group projects. So when I was going through Platoon, our group project. So typically, what you have to do is you have to pitch an idea to of what kind of project you want to do for your group work. And then the instructor has to sign off on it, like, all right, cool, it covers everything that we require. Typically, what it requires is first and foremost, you have to use the technologies that were taught to you. You have to use two APIs. It has to have user login authentication and a couple other things. But our group wanted to do something a little bit, unconventional. We wanted to go against the grain, um, and we wanted to make a game, right? They didn't teach us this, but we wanted to leverage the skills that we have learned throughout Platoon to try something new and see if we can make something that hasn't been done before. So we decided to make a game. So we had to learn how to use a let's call it a software, right? A software to build games. I'm sure for those of you who play video games, you've heard of stuff like Unity or Unreal Engine. The software that we went with was Godot because it's the only one that didn't have to use C# or C++ to make games. It uses a language called GD script, which is essentially just an imitation of Python and JavaScript. So it was very easy to pick up if we since we were learning something new. Um, and this gaming engine, what happened was when we were trying to use GitHub, it didn't play very nice, right? When adding our project onto GitHub, what would happen is we had to upload our assets, right? So for games like for first and foremost, it was a roguelike pixelated game. Um, so the characters, the artwork of the characters were pixel art, right? They were like 32 by 32. And we had to upload these files onto GitHub. Well, it didn't play nice. What we came to find out is when we upload these files onto GitHub, um, someone else would decide to use the version of the game. And I was working on the main hero, and there was somebody else working on like the main map. So what they would do is they would use my hero and drop them into the main map to play to see if it was working correctly, right? If they had the collisions of the game working, so whenever it ran up to a wall, it didn't walk to the wall, it actually stopped. But well, come to find out, if I made any changes onto the main hero and they had the hero in their map, it would corrupt the file, right? And what we had to do was essentially go through GitHub and look through previous versions where our code was working. What made it even more difficult is that because they're picture files, unlike a Python file that you can open up and see the contents of it, a pixel file, or sorry, a picture file, a JPEG, it's binary, right? It's a bunch of ones and zeros or just random numbers. It was code that wasn't human-like. So we had to find a pattern within like our files to see which pattern matched the code of our image, and then just delete it off the file and get it to work. So it was a lot of going back and forth. And I probably recreated the main hero like 6 or 7 different times. Uh, Absolutely horrendous. But GitHub allowed us to go back to a different save point in our project to ensure that we didn't restart from scratch. So it allows you to create save points or essentially backups where in the event something breaks or doesn't go how you plan for it to go, you're able to not lose your entire work and kind of go back to a state where you knew that everything was kind of working. Any questions? All right. Instructor example. Okay. Let me see. Give me a second before we continue. Uh, okay, let's go through these slides before I go to the example because it'll make more sense. Um, so all our snapshots or commit are local. So what happens if my computer stops working? Local versus remote. Share. So as I mentioned to you, on Git, your local Git repository, as you progress through your project, it takes a snapshot. And let me see if I can find it. Stand by. I'm going to try to see if I can find Git in my directory to show you. Uh, 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 um, Give me a second. Awesome. Here's a directory of that project, right? When you guys saw it here, it's not present, right? It's just the README and the module directory that I had created. Excuse me. Here is the actual file explorer, the same location that I just showed you from my terminal. That is what we are looking at. And I want you to notice that there is a Git file. You couldn't see it before, but when I open it up, there's a couple things here, and I don't want to keep poking through everything. But I can see the branches I have. I didn't create any branches. I just went straight to main, which is not good practice, but I was lazy. Um, and this Git logs references as I don't want to open up or mess anything up around here. You don't ever want to touch your Git folder. If you are having to mess around with your Git folder, you screwed up. You did something wrong. Right, but this Git folder, what's happening is I'm working on my project. It uses this Git folder to save the snapshots onto one of these files. I don't know exactly which one it is. It might be this one right here. Like I said, I don't want to mess with it, but uh, it creates save points. That's the file that it uses to track your progress of your work. Right, so uh, let's say I do some work and my computer stops working, right? And I lose everything on my computer. Do I lose my entire program if I was using GitHub? No, right? I might lose whatever work I was doing recently that I didn't update on GitHub, but for the most part, the last version that was uploaded onto GitHub will be there, right? And that's the beauty of GitHub. You know, they store it for you, so nothing happens to your work. And there's different versions of GitHub, right? We have like the regular GitHub. You can use like enterprise versions for for actual other companies, but GitHub does allow you to do that, right? We have two different things: local versus remote, right? And it's kind of in the name. What is the local? What is the remote? The local is your that directory that I just showed you, that .git directory. That is the local Git repository, the local Git version control that's holding everything on my computer. The remote version, it's whatever GitHub is holding for you. All right. So working with Git and GitHub, there's a couple commands that you're going to need. And this is probably where we'll go from here. First and foremost, these are going to be the top three commands you'll probably use the most: git add, git commit, and git push. Right? Git add, git commit, and git push. To actually initialize GitHub on your computer, you require the git init method, which is going to start something locally. And to show you that, I can do something like this. Let's go ahead. I'm going to open up my terminal. If it loaded, there we go. I'm going to go into example directory. And I'm going to make a new directory, which is going to be my project here on my computer. Make directory git underscore example or git dash example. And I recommend you guys kind of follow along. I usually don't do it this way. It's easier to do it through GitHub, but I'll show you both ways. There's two ways that you can connect your GitHub project to itself, to your computer, or vice versa. The method that we're doing here is in the event that you start your project first on your computer, and then later on you want to send it up to GitHub. Right, so let's say I just go ahead and I start. I create this directory that's going to hold my project, git example. And I'm going to go inside this project. What I'm going to do is I'm going to start git, right? Git init, right? It's going to create a special folder to hold my commit, as you saw earlier, that .git directory, right? It essentially starts tracking everything that you do. As of right now, I have nothing in here, right? I list out everything within the directory. There's nothing present. So I'm going to use git init. Actually, before I do that, I'm going to do this in my VS Code. So I'm going to do code dot, and it's going to open this up in VS Code. You could do it here, but I'm going to do it in VS Code so I can make changes to my files and it's easier to follow. Because the terminal that you initialize GitHub is where you're going to be working on. Right, here's my Git example. I'm within the directory, right? I have nothing in here. While here, I'm going to initialize my GitHub. So git init. You'll get a couple of hints, nothing crazy, nothing to worry about. It just gives you kind of like warnings or like helpful things to keep in mind. For example, using master as the name for the initial branch, this default branch name is subject to change. It tells you that you can change the branch name if you like. And it tells you that the names of master, main, and trunk and development are usually like synonymously used. They're interchangeable, so you might hear one or the other. Just understand that they're talking about your master branch, whether they use master, main, trunk, or development branch. That's what it's referring to. And what really matters here is this line right here where it says initialize empty Git repository. So it tells you that inside of the home Roger example directory that I created, inside of the Git example directory that I created for my project, it added a .git method or a .git folder, right? This is inside of the Git example. I just created this one. This is supposed to be my demo for GitHub, and it created a directory within here. If I list it out, I don't see it. As I showed you earlier, you won't see it unless you open up your file explorer. But the .git folder is in here. And now it's tracking any changes that I'm making in here. So I'm gonna create a new file, touch git python example.py. And you're gonna see something interesting here. It's going to create the file, and to the right, you're gonna see a U. That U stands for untracked, right? Untracked. That means this is not saved onto GitHub, right? Nothing has been added and saved onto GitHub. That's what it means by untracked. I'm gonna come in here and I'm gonna add some simple code, print. This is my GitHub example. And I don't know what is going on with my computer that's so slow. Cool. I'm gonna go ahead and save this. And then I'm gonna make a readme. I'm gonna call it readme.md or touch. What is going on? I'm sorry, I don't know if it's my keyboard or what it is. I think it's my keyboard. Okay, readme.md. Yeah, sorry for that. Touch readme.md. There we go. Uh, this file that I just created is standard across repositories on GitHub. It's essentially just like a markdown file, right? Typically, when you create a repository on GitHub, it'll ask you if you want to create one by default or not. I'm just creating in here. This is my README file for my GitHub example, right? I'm just doing this so I already have it, and I'm gonna save it. But nothing too crazy. All I did was just add some change in here. Now, the next step is to I'm gonna go ahead and do git add. And it's not gonna show anything, right? Git add. So I created my repository, or not my repository. I created my directory. I initialized Git, which created a Git folder, and then I started working on my project. My project, as it is right now, it's only 2 files. Now, let's say I'm done with my project, or I've gotten to a point that I feel very comfortable with, and I do not want to lose it. The next step is that I want to prepare my files to send them up to GitHub, right? As of right now, what I did was I used the command called git add. Now, what is git add doing? The best way I can explain it is by using a factory analogy. All right. Let's say this is a factory, right? Um, inside this factory, I am creating changes to my project, right? New files, right? This is the machine that's going to create new stuff for my project. I'm creating the new files, whether it's Python files, JavaScript files. Cool. They're still in the factory. They're being made. This is me. The analogy is me working on my project. as I'm working on this, what's happening is that I'm producing new files, new content, new features, new stuff that's supposed to go to my project. Right? It's coming out, and what I'm going to do once I feel comfortable that I have a good amount of files or work or progress in my project, what I'm going to do is I'm going to grab my files and I'm going to put them um in a staging area, right? In a staging area. Well, how do I do that? Well, to stage them to get ready to head out to GitHub, I use the git add dot. Now you don't have to use a dot. Specifically, what you're looking for is this, the git add command. You're telling your git version control that you're about to add something. Well, what are you adding? By default, the dot stands for everything, right? It means all. But you are able to do something like git add py or example.py. So if you didn't want to add every single file to your staging area, you could specify what you want to add. But because this is my first commit, I want to move everything to GitHub. I use a dot method, and it's going to take, and we'll use a circle for this example. There we go. This is the files or my project, my work. It's going to take all this. It's going to put them in the staging area, right? Let's call it the staging area. Dude, what is going on? My keyboard is tweaking out. I'm sorry. Staging area. There you go. Cool. All right. So whenever you use the git add command, it's going to take all your work. It's going to put it somewhere in a corner that we like to call the staging area. This is just kind of, you're ready to move stuff, but you're not ready to actually send it out. You're staging it, ready to package it up, right? You can remove things from your staging area or add things as necessary, right? There's another command, I don't remember off the top of my head which one it is because I don't do it often, but you can remove things from your staging area. You can remove it all or remove it one at a time. You can keep running git add over and over again until let's say you add something to the staging area, but you're like, oh, I need to create this before I send it up. Let me go ahead and create this new file. You can run git add again, keep adding things to your staging area. Finally, you decide, okay, I'm good. That's it. I have no other changes. I want to send this up. The next thing in this analogy is to package up our files, right? Kind of get them ready, packaged up, ready to send them out to GitHub. That's what we call committing, right? We're going to commit these files. And in this analogy, what we're doing is we're boxing them up and loading them up in a box truck. That's how I like to say it is. Git commit, right? Gets the files ready to send to GitHub. Right, these are two different things. Now the git commit, it's going to take everything in the staging area. Everything in the staging area is going to put it all together, and you're going to send it out with a message, right? Git commit -m. And here you can add a very brief message to explain what this commit is. It can be something as simple as like fixed example.py, right? This is very, very, very simple and not specific at all. You want to give a much better message to explain what you're working on. Typically, what happens is when you're working with a company, you would have some kind of naming convention of how you would name your git commit messages. It might be some code. It will be something like your initials, an ID number, and like if there's different parts of your project that you're working on, you might label certain things with certain codes. So you would do something very similar to that, where you'd be like, for example, my initials are RD, so I would do like RD, this code to specify that I'm working on this feature or whatever. So you might have different standards like that. So for now, if you're not doing that and that's not a standard, typically the commit messages are something to represent what this is. Uh, you aren't allowed a lot of input here. If you try to put a lot on your terminal, you will be able to put it, but when you see it on GitHub, it'll cut it off. So just make sure it's not too long. I don't remember what the max character limit is. Just make it brief and straightforward, right? So the commit method is going to grab everything from the staging area, and you're going to attach a message to it. So when it gets to GitHub, we are able to see what is being used. And next is going to be, here's my box truck. It's not the prettiest box truck, but it'll do. Let me do my circles. Yes, sir. All right, cool. But here's my box truck, right? This is me sending it out to GitHub. So I've already added to my staging area. I've worked everything I need to work on. The next thing is going to me package it up and send it out to GitHub. So then that command from the git commit message to the send it up to GitHub is going to be git push. Git push. Right, what git push is going to do is actually load it up. Right, it's going to load it up into the little box truck. It's going to send it out to its destination, which is going to be GitHub. Right, git push is going to take everything that you've committed and send it out to GitHub. Right, pretty straightforward. Exactly, like nice little analogy to explain the process of how this is working. This is the most basic concept of it. Let's actually talk a little bit more about these. Right, so we talked about getting it. The getting it is going to initialize this folder that's going to keep the snapshots of the version that your project is currently in. The next step is going to be to add it to the staging area. As you see here, you specify what you want to add. You can give an individual file name, so it adds files to a staging area, or you can do add all the files, right? I see your hand up, Andy. How can I help you?
Just a quick question on that git commit. So if let's say you and I are working on a project, and we didn't do like your daily stand up, figure out who's working on what, right? And we're both going to tackle the same subject. I have certain idea of solving the problem, and you have a certain idea, and we're both working on the same thing. Which one does the version control would pick? Is there a hierarchy for whose commit is overwritten? Kind of understand what I'm saying?
I do, but when you send out to GitHub, it doesn't automatically merge, right? It doesn't automatically merge, and you're gonna see that in a little bit. I feel like your answer will be given to you once you see how it looks on GitHub, right? Just because I say git push is not going to automatically update my repository on GitHub. There are some additional blocks that it has to get through, or I guess like safety measures to prevent stuff from being overridden. And that gets handled through the browser side of GitHub. And we're going to talk about that very shortly here. So I know I didn't answer your question yet, Andy, but it'll make sense once we get to the next part. There is no hierarchy. Someone has to manually approve the change. And you'll see that in a little bit. Keegan?
So does the git commit command, does that also function as a save, like a save all, or no? Do I need to save it and commit it?
It can. Okay. As a save all, you're referring to like if you lose something, or if you delete your folder, you can go back to that commit. Is that what you're referring to?
Yes.
In essence, yes. You can go back to that. You can actually look up. So the commit is going to be tagged with a type of code, right? It's going to be this very long series of numbers and letters, and you can actually use this to actually go back to a save point. So yes, it can be used as a save all in short. I've used the commit history. Yeah, no problem. But all right, so we have the git add, which adds everything to the staging area, and then the git commit is just getting everything from the staging area and sends it all together to GitHub, right? With a pretty nice little message. We have a couple other commands. The next one's going to be the git status. It shows all the files in the staging area. And you're going to see here that I don't have anything in my staging area. So on branch master, so it's telling me when you running the git status, it's telling me what branch I'm in. It tells me how many commits I have made. I haven't made any commits yet. Changes to be committed, right? It shows me what new items I have that I can commit, right? Because I did create 2 new files. All right, I have not committed anything. They're in the staging area, and I'm pretty sure we can check the staging area. Here, this git log, I believe. Shows the history. Yeah, let me check real quick. I'm pretty sure it's git log. No, I'm dumb. Let me see the other command. There's another one. I'm sure there's a command for checking what's in the staging area. Yeah, I think it is git status. Yeah, my bad. I'm tweaking. Git status does check the staging area, right? Changes to be committed. This is the staging area, right? And it even tells you use git rm -- cached to unstage, right? The unstage. How is this the staging area? Well, remember earlier I used git add and the dot. So this is my makeshift quote unquote staging area where I'm putting everything to the side and ready to commit it. So this has been added to the staging area, but it has not been committed yet, right? So that's how the git status work. And as we just answered, the rm remove, right? The abbreviation for remove dash cached is going to remove files from the staging area. So you want to specify these, right? I don't think it's going to remove everything unless I do git remove. Let me see if it works. Cache. Yeah. It doesn't know how to handle all the files, right? It even tells you like not removing recursively without -r. So you have to specify. I'm going to assume it's going to say remove -r. Let's see if this works. There we go. Right, so I am able to delete all of them, but I have to use the flag for the -r, which stands for recursively. Let me go ahead and do git status again. So now notice that these are no longer green, or earlier they were green. It's just untracked files, so they're not in the staging area, right? Or before, if they are in the staging area, it tells you what needs to be committed, and what's telling you that this is in the staging area. But let me go ahead and do git add again. And then git status. And there you go. They're back in the staging area. Cool. I'm going to take a slight tactical pause. I'm going to go on a 10-minute break. I will see you guys at 6:44. This is the first hour of tonight. I'll see you guys in a bit. So the question is, if I create a program using an older version of Python, like 3.10, because if my project is probably in 3.10, is there a way to ensure that if I send it up to GitHub, people know that they need 3.10 to run my program, or something similar to that kind of scenario? And let me answer it this way. First and foremost, when you load up your any project to GitHub, what you're going to have is going to be a requirements.txt, right? This is pretty standard for most people to do. You're going to create a file where you're going to put everything that your project runs on, right? So if you're using Python, what version of Python? If you're using different frameworks, what version of that framework? You add all this to a requirements.txt file, a text file, right? And this is included with your program, right? So if anybody tries to use your program, what they would do, there's a way where you run a command, and what this command will do is going to read through this txt file and install everything that it finds on this txt file. So there's a command for that. There's a command for your computer to automatically take a snapshot of what you're using that's installed and save it into this txt file. So you don't have to go manually or remember everything. There's a command for this that you can dump all your installed, software, languages, installations, whatever you're using into this TXT file to keep a record of it. It's called pip freeze, right? Um, and the way this works is that also what you'll do is whenever you start a project, you're going to create what's known as a virtual environment, right? And you guys are technically working something very similar to that, right? For those of you who have Weasel, this Windows subsystem for Linux, it's almost a version of a virtual environment. What you're going to do is create this virtual environment. It's essentially creating a little sandbox, a little closed up space somewhere in your memory where you can work on your project where nothing else is affecting it. Right. So right now you have Python installed, you probably have 3.12. For those of you who have 3.10, you might have 3.10. Right. You have different things installed on your computer. So when you create a new project, you don't want these installations to impact your project. So what you're going to do is you're going to create a virtual environment. You actually installed it during the install phase. It was Python on the install phase. It said Python 3.10 dash VENV. It's a module. I believe it's called module. I'm pretty sure it's a module that comes with Python that allows you to create a virtual environment. It pretty much creates a like a like a like a clean room with nothing affecting it that you can install things from scratch. Let me show you how that works actually. Let me create a new directory here. I'm gonna go and come back to my roots. I actually have a folder for ENVS's environments because I knew I was gonna do it. I'm going to create a virtual environment. I'm gonna say Python -mvenv. Right. What this is saying is, hey Python, I want you to run a module called a virtual environment, and I want you to create a virtual environment inside of the ENVS folder, and I want you to call it uh test env. It's gonna run it. Give me a second. There we go. Let me go ahead and go into my ENVS file. I list it out, and there it is. So here is a virtual environment. Now, when I want to create a new project, what I'm going to do is I'm going to activate this virtual environment by calling source, and then I specify where this virtual environment is located at, and I believe it's on source. I'm trying to remember all this through memory. I'm sorry. Test env bin activate. There we go. So there's a command that you run. If you call the source command and you specify the environment you're trying to run, and then you end it with /bin /activate. And what that's going to do, it's going to show you that it's now running a virtual environment. So currently, I have a location here that I'm running that I'm able to install different things. For example, I can say, I'm pretty sure I can do Python --install. I don't remember the Python installation. Is it sudo? I forgot. Give me a second. If someone knows from the top of the head, let me know. Linux command to install Python. It's sudo app. Here we go. Sudo. Actually, before I run this, I want to show you what's installed right now in the virtual environment. I can run a command called pip freeze. And it didn't print anything out, right? Because there's nothing saved in there. Now let me see if I can install Python to show you how this works. Sudo app.get install Python. Let's go with 3.10. I think it installed it. Pip freeze. How do I check it?
I think it's pip 3 version, like tac version.
Pip freeze local. No. I have not done this in a hot minute. Give me a second. So I installed it. Okay. Okay. I'm going down a rabbit hole here, but um, what should have happened? I don't remember the commands off the top of my head. Uh, but what should have happened was I should have been seeing all this. Let's see if I can do Python uh Python dash m pip freeze requirements dot txt. Okay. Uh, let me see the requirements dot txt. Uh, okay, it didn't add anything because I don't think it installed Python. Uh, I'm a little rusty on this, but what should have happened is I would run this virtual environment. I was able to install different things, and then I can do something like this where I say pip freeze and I specify what I wanted to freeze it into, and then the name of the file. Because it didn't exist, it created it. But what you do is when you run like the pip freeze command, it's gonna check everything installed in the virtual environment. It's gonna save it in the txt file. Unfortunately, I wasn't able to install Python. What if I do pip install Python? We'll do it a different time. I'm sorry. I get very sidetracked. But yeah, so you would do something very like this, right? And you would attach it to your project. So whenever you bring it down from GitHub, there's a command very similar to this, right? Where you say like pip install requirements.txt and it'll run through the entire file and install whatever was saved in there, right? So that way, whenever someone copies your project, they create their own virtual environment. They install the dependencies that you added to the project, and they can run it. Does that make sense, Daniel? Did I answer your question? I know I went on
Does.
kind of a tangent, so I do apologize. But there is a way that way, if you are working on an older version, it can still work, right? And other people can still use it. You will learn this as you progress through the immersive program. I'm a little rusty on this part because I've been worked on a big project recently. So these commands are not commands that you run often. These are run like a couple times, maybe like 2 or 3 times throughout your entire project. Obviously, probably once you're about to stay into GitHub or when you're done. So this isn't something that I know off the top of my dome because I don't do it every single day, but I know that it exists. I just don't want to waste y'all's time looking for the command right now. But hopefully that does answer your question. I'm sorry if I wasn't able to give you anything specific and very direct that works off the moment right now. Uh, but yeah, let's go ahead and continue from where we left off. If I want to leave this virtual environment, I can run the command deactivate and it'll leave the virtual environment. Let me go ahead and remove requirements.txt. And I'm going to remove recursively the test env. There we go. And now we are back in business, baby. Let's go into example directory. I'm in here. Here's my git example. I'm gonna run git status, and there we go. My git's still initialized, right? Nothing's crazy. I can still see that my stuff is still in the staging area. So let's go ahead and continue from where we left off. The next part was actually connecting it to GitHub. So let me go ahead and open up GitHub. Here is my own individual GitHub. So for all of you guys should be somewhere around here where you've added everything to the staging area. And I want you to make sure that you also have GitHub in a different browser, so you're ready to do the following. All right. So the next step, as you guys recall, after we added everything to staging area, is next is to commit it, right? So we want to commit it, but before we do anything else, um, let's go ahead and actually try to let's commit it actually because it won't work. We need to push anyways. When I say git commit, right? So we have the staging area, but we're ready to package it up. We want to grab everything from the staging area and get it packaged up with a nice little message so we can send it out to GitHub, right? And this is going to be something as simple as this is my first commit, right? Notice how I wrote it. It has to be git commit space -m. The -m stands for message space, and then the actual message has to be in quotation marks, right? So it knows what your message is going to be. And then you press enter. Notice that it has 2 files changed, 1 insertion, and then I inserted this. Okay. Well, we talked about git push. If I press or if I type in git push, who can take a guess what's going to happen?
I can't guess, but I just did it. I can tell you.
Yeah, it's going to give me an error, right? It's going to tell you no configured push destination, right? Because it's not connected, right? Local git, right? Your local git version control, it's only on your computer, right? So this project currently only exists here. If I do git push, I have not connected it anywhere. It doesn't know where its destination is going to be. So it tells you either specify the URL from the command line or configure a remote repository using the following commands, right? And this is a command that you're going to be looking for here, get remote as. We're going to use this, right? So now it brings us to GitHub. We have our project, our local Git project with its own version control on our computer. But here is where GitHub comes into play. We want to send it up to GitHub so it keeps track of it. So what you're going to do is you're going to go to your repositories. And I got a couple I don't need. Let me delete the test one. What was this? Yeah, it was a test. Okay. This is why I have like random ones, example repo, and stuff like that. Let me go ahead and delete the example repo one. Settings. Delete this repository. Of course. Hold on, give me a second. I got 2-factor authorization on my phone. I don't know why GitHub is so annoying. Every single time. Okay, I'm having issues with GitHub. It's okay. Let's go ahead and back up. I think I'll use my password. Example repo. There we go. All right, cool. So I'm going to create a new repository. So you should all be on your GitHub. Everyone's GitHub, it looks a little bit different. We'll talk more about GitHub in a little bit. But this should be like your GitHub repository, what it should look like. Right? I have a bunch of random ones. They're honestly all trash for the most part because I use it a lot for explaining this process. But what you're going to do is you're going to click on new repository, and it should bring you to this page. Am I sharing? I am,
Yeah.
right?
Yeah. Yes.
Okay. Usually when I'm sharing, it shows like a green light, and I didn't see it anymore. You can use a template. If you have other repositories that you work with, as you can see, I have a bunch of repositories from Platoon. But usually, for the most part, you're going to start with no template. You're going to choose the owner, it's going to be my personal GitHub, so I'm going to choose me. And then you can give it an example name or repository name. Great repository names are short and memorable, need inspiration, that's trash. Let's go ahead and give it a unique name. I'm going to say example repo, pretty unique. Nobody else has done this before. So, yeah, I see Justin has his hand raised up. Yes, Justin.
So I guess I missed a few things, but when we initialize the repository locally with the git init, is does that not automatically take it to your GitHub hub and create the repository there? And if so, like, is there a way to, I assume we can name it from the command line, but is that automatically created with like some boilerplate name?
Yeah, so that's a good question, right? So Git and GitHub are going to be two different concepts. Git, it refers to the local repository on your computer. And once again, right, what do I mean by repository? It's just a fancy name for folder, right? Your local folder for your project on your computer, right? So that's what Git is. You actually installed Git during the install phase, you guys remember, right? And then you allow that connection between your actual GitHub and your computer. So that's how it knows who it's really speaking to. But when it refers to the Git, I'm gonna show you how it looks like. Here is my Linux machine. I was in Platoon inside of FOP. I think I was in here. Where was that?
So the repository on GitHub is a completely different repository.
Correct. Two different things. Right now, the GitHub repository does not exist. I have not created a repository that's going to hold my project. Right now, yes.
Oh, I guess I'm working a little bit ahead in my mind here, but so when you commit things to that Git in the repository, in your local repository, would the next step be then to like send it to your GitHub? Like,
correct.
And is that done typically through the command line?
Yes, it's going to be done through the command line. And that's what we're about to do right now. We're going to create a repository on GitHub where we want to store it.
So just so I can get everything straight, so you have your whatever your working document is that isn't committed. Then between that and your local repository, you have a staging area. And then after the staging area, you send it to this local Git. And so these are two completely like buffer levels between your actual Git. Is there a way to like take things? I guess I'm wondering what the function of the local Git is.
Right. So we did already talk about it, but I'll touch up on it again.
I'm
right.
so sorry.
It's okay. No, I want to make sure everyone understands it because even if I already explained it, there's probably some people here that are trying to wrap their head around it. GitHub is essentially like the cloud, right? How when you back up your phone data, or when you back up your photos on Apple Cloud, right? Stuff like that, right? You have a server on GitHub that can store these things for you, so you don't lose them, right? What happens if you break your phone or it stops working, right? If you don't have your phone backed up somewhere, you will lose everything on your phone. So that's what GitHub is. Essentially, is a some kind of like remote storage location where you can hold your repository and collaborate with other people while also working off the remote repository.
This makes sense. So like you could actually even have your local Git be in some like external storage device nearby that like you could have if you wanted to work off the grid, right? Someone else connected to and be sharing that way. Because it'd still just be local version control.
Right. So it's to not have to do that, right? We have GitHub, so everyone can
I was just trying to separate them in my head.
Yeah. Right. So your local repository, what happens is when you are ready to create a project, you run the command that we mentioned, which is the git where's it at? We run the git init command, right? Which is going to create a special folder to hold the commits on your computer. Right? That's what ended up happening. Why? There we go. Right, that's what happened when I ran the get init method, and I'm all the way down. Let's see if I can find it. There we go. That's what happened when I ran get init, right? It initialized the tracking of my project, right? That's the way that your local Git works. It creates a folder in your computer that it's going to use to save all the snapshots of your work, right? This is that folder it created. Notice that I'm within the current directory that I created my project, the Git example. These are the two files that I was working on. You don't see it in my terminal when I go to it, right? Right, see, I listed out these items, but there's no Git folder. So it's typically kind of hidden from you. But when I open up my file explorer, I see that it exists. This folder is holding essentially save points, like checkpoints in the game of all your work. So in the event that something happens, it's able to track what work I've done. So that's the Git init folder. That's what it created when I ran Git init. The next step was actually to do some work. So I created the Git Python example and the README. And then in this analogy or this example, I'm ready to send it up to GitHub. So the next step was to run the git add method, which in short works as a way to put it all in a staging area, right? So git add is gonna take all your files that you created, it's gonna put them in a staging area and move them aside, pretty much saying, hey, I'm doing some work, I'm gonna put them aside, get them ready to commit them later. Once you're done with all the work that you want to do, the next step is using the git commit method, which is pretty much boxing it all up, right? Putting a nice little label on it, which is a message, and preparing it to send out to GitHub. So git add puts them in the staging area. Git commits takes everything from the staging area and prepares it to send it out all in one folder with a nice little message. And the next step that we're trying to get to is going to be the git push method, which is what I just ran. But when I ran the git push method, if I do git push, I get an error here, right? That it says that it doesn't know where to push it to. And that's going to be the next part. As of right now, my local Git is tracking the progress of my project, but if I'm trying to send it anywhere else, it doesn't know where to send it because it's not connected. That's where our GitHub account comes into play. Does that make sense?
Yeah, yes, it all made sense. This makes a lot more sense now. Thank you.
Yeah, absolutely. So let's go ahead and see if we can go back into it. Where is here we go. Okay. So here I am going to go and create the repository on GitHub. It's going to be an empty repository, but this is where I'm going to send my project to. I essentially need to just create the folder so I can send it up to this folder here. So we gave a repository name, and it's optional to give it a description. You don't have to give it. And the next step is going to be to either make it public or private, right? You can see here what these mean. Private means that you choose who can see and commit to the repository. And public means that there's other people that can go to your profile on GitHub. They can see your repository, and they're actually able to use it and actually make updates that you have to approve, right? But they can make like suggested updates like, hey, I got your project. When I was working on it, I figured out, there were some issues with it. I fixed them for you. Here's my changes. Check them over and see if you like them. And if so, maybe update your project with them or not. So you can do public repositories and collaborate with other people. For this example, I'm just going to go ahead and keep it private, but either one, whichever one you use, it's fine. Doesn't mean that they're going to mess with your stuff. It just allows other people to collaborate with you if you want to. And as you see here, the next option is adding a README file. So by default, you are able to add one or not. The README files, the purpose of them is kind of to give an explanation of what your project is doing, right? You can give it a long description of the intended use of your project. And then here's also where you would add like a commentary about how it should be installed, right? if there's some specific requirements for your project that someone needs to be aware of for them to use your project, here's where you would say like, hey, you want to ensure that you create a virtual environment. And then after you create your virtual environment, you want to, use the requirements.txt file to install the dependencies because it is running on a 3.10 version of Python. It requires these installations, yada yada. Throughout the installation process, if you run to this issue, just do this. So this is where you would do all this stuff. You let other people know the left and right limits of your project and how it's intended to be used. Right? Any questions so far? I already created the README. If you guys recall, I manually created it when I made my project. So I'm not going to add it here because I don't want an additional one. The next option is to add a git ignore file. Right, this is optional, but the git ignore file is a very powerful file that you're going to want to use once you start your personal projects. And the reason for that is because when you start working with your different frameworks or if you start using third-party APIs, a lot of these things is going to require what's known as a key, right? Is anyone familiar with these terms, like using an API key or a secret key?
Yes.
Okay, Nick said yes, right? So certain frameworks or certain projects, APIs, what they'll do is they'll issue or assign to you a key that's specifically for your project. And these keys are used to pretty much do certain things with your project. And if you don't have these keys, they won't work. But you don't want these keys to be on GitHub, right? Because people can take your keys, for example, and this will make a little bit more sense once we start working with APIs. If you add your API keys on here, people can use your keys and then use your account to use the same API that you use. Typically, APIs, they'll charge you for how many times you ping their API. For the most part, a lot of them are free, up to certain amount of usages. Some of them vary. Some of them will give you 50 usages, some 1,000, some 5,000. It varies on API. But these keys are linked to your account. So if you're using an API and your project's heavily dependent on this API, and you're paying a subscription to this API, you don't want other people to use it because you end up having to pay all these additional costs because someone else is using your account, right? So the git ignore, what this does is it allows you for you to store all your keys in a safe location, and when you upload your project onto GitHub, it doesn't upload your keys, right? That's what the git ignore file is doing. It's going to, so whenever it uploads the file, it's going to say, hey, is there a git ignore file? Okay, here it is. I see there are some keys in here. I'm not going to upload this. I'm going to leave it behind, but I'll take everything else, right? So the git ignore file is used for that. You specify what you want your GitHub to ignore when adding something new to it. And then the licenses tells others what they can and can't do with your code. Don't even ask me what the licenses are, which one is for what. I don't know. I don't use these often. Most of the stuff I use is like public use. Most of our stuff at Platoon is open to the public. So we don't use any licenses and I haven't had to use any of these. So don't ask me for these because I don't know. If you want to know more about it, I can look more into it. Just let me know. But as of right now, I cannot give you an answer for any of these. But yeah, that pretty much covers the creating of a new repository. And after that, we just press create repository. And it should bring you to this page. If you didn't know, or let's say you go a couple months without using GitHub and you forget how to navigate with GitHub, it's going to give you some new, a walkthrough of how it's done, right? It tells you, quick setup. If you've done this kind of thing before, it will give you the links. If not, it will walk you through it, right? Notice that they created some kind of file, example repo. They initialize their GitHub or their local Git. My apologies, I misspoke. They initialized Git on their local repository. They created a README. They went through adding it to the staging area. They committed it. Here's gonna be the next step. Git branch -m main. What is this doing? What this is doing is going to change the name of your main branch. Why do we do that? Well, if I run the command git branch, what does it do to me? When you run git branch, it's going to return to you all the branches you have, right? And it's going to tell you which one you're on. I never created a branch. We have yet to do that. But but I do have one branch, and this is a default branch that every project has, which starts with master, right? Recalling back to earlier, the master branch is the main branch that holds your actual project. This is where your project is living on, and by default it starts off as master, but GitHub calls it main, right? GitHub calls it main. So what this is telling you to do, it's telling you to git branch. The dash M stands for is referring to the master branch, and then it's telling you to name it to main. So this line of code is making you rename your master branch to main. So the naming convention of your local Git and GitHub are matching. That's all it's doing, right? Because as of right now, both of these are referring to the same thing, but they're calling them something different. So it's telling you to change the name to make sure it matches with whatever GitHub is using. So let's go ahead and do that. We're going to say git branch dash M main. Let me run git branch again, just the git branch. And notice here that the branch is now changed to main, right? So all we did was rename our main branch to the actual term of main. Any questions so far? Cool. Notice that the branch I'm on has the asterisk. If there was other branches here, the one that was currently located on would be the one with the asterisk to the left of it. And it's very important to know what branch you're on before you start making pushes to your GitHub. But the next step is going to be this command here, where it says git remote add origin, and then it's a URL path, right? And you can kind of already tell by what the code is saying. It's telling you to, for your Git, to add a remote branch, right? I'm remotely adding an origin to where this should be linked to, and that origin is going to be this link, right? And it's actually fairly similar to the same command it gave us earlier. Look what happened when I tried to push earlier. It told me to run either one of these, right? First and foremost was this one, which is for me to add an origin point for this to get linked to. Notice that the first thing is called name, and then the next thing is the URL. So this is the name of where the origin is going to be at, and the URL of that origin. So I'm going to say git remote add origin, and then I'm going to copy this link right here, and I just copy and paste. Finally, I run this. No news is good news, right? So although it looks like there's nothing happened, it did connect it to my main branch. Notice here, there's nothing, right? It's still at a default stage. The next part is going to be to actually push this to GitHub. So right now, as it stands, my project is linked. Now, finally, I can push up my changes up to GitHub by using git push origin main. So git push, I believe the U stands for up, origin main. And it's going to run this real quickly. All right, a lot of stuff is happening here. It's just pretty much like the loading or the progress bar of what it's doing, of how it's getting everything prepared, compressing it into how big of a size it is. And then it tells you to where it's going to. And then it says that it had a new branch called main. It says branch main set up to track origin main. Let's look at my GitHub. I'm going to refresh my page. And there you have it. I now have my project that I had on my computer up on GitHub. Do I have any questions on how this was achieved? Okay, I think we're all doing good. So what's another way of doing this? The other way would be something like this. I'm gonna go ahead. I'm gonna close this up. I'm going to create another folder. Right, so this was my Git example. I'm going to create Git example 2. Oh, my bad. Make directory Git example 2. There we go. Here it is. I got 2 folders. Here's the first one that we just ran through. And here's my second one. Git example 2. Let's go ahead and go into my new one. So cd Git example 2. All right, I'm in here. Notice when I list out everything in here, there's nothing. It's a brand new directory, right? Here is the way that you would do it if you wanted to grab an existing one and bring it down, right? It's very similar exactly to how you did it for the curriculum. You're going to copy this URL. You're going to actually, let me go ahead and open this up on VS Code. Code Git example 2. I'm opening on it, so I'm already have the terminal here. All right, there we go. After I get the URL, it's as simple as saying git clone and then giving it the URL. It's going to clone it down. And now we see here that my example repo came down. Let me see if I run git status. Okay. Nothing happened when I ran git status. And I think it's because of where I am in my directory. Let me go ahead. I'm going to go into example repo. I'm going to cd example repo. All right, there we go. I'm inside the repository clone. Let me say git status. And there you go. There you go. It says git status on main branch. Your branch is up to date with origin main. Nothing to commit, working tree clean. I was able to bring it down, and my Git is already initialized for this folder. Do you have any questions on how that works? All right. Well, we talked about creating a new project, connecting it to GitHub. Let's go ahead and continue. We pushed to GitHub. That's cool. We have the Git example. All right, let's continue with the messages. So we talked about Git status. We talked about remove cache. We showed Git log. Git log, it won't show anything right now because I haven't made any commits. Oh, I did. When running Git log, it showed the commits of this project. And here is what I will refer to, Keegan, right? Whenever you make a commit, there is a long code that's created that's referring to that specific commit. You can use this to kind of go back in time to a certain save point of your folder or your repo.
Gotcha.
Here's a nice little message, and it tells you when this commit was made. So you can kind of, figure out when was the last time your project was working, and then go to a commit that matches the dates of when that was, and you can just use this. I don't know the command off the top of my head, but there is the command to go back to the save state, but I'm not gonna do that here. All right, you guys did this along with me. Let's talk about branches, right? And this is one of the best things about GitHub, the branch system, right? One of the best features about GitHub is that it allows us to branch off our project, right? It's cool that we're able to track the progress of our project, but what if we want to expand upon it, right? We are able to create what we call branches. It uses a tree, like a tree concept, right? The main branch is really your trunk, right? That's your main tree. That's what's holding your actual project. But you're able to diverge from your tree and go different ways and then come back to the trunk whenever you're ready to merge your project with a new feature. And once again, here's another version of that initial diagram from the initial part of our slideshow. Here is the timeline of your master branch. At some point, we branch off from here and create a copy of the master branch, because that's what it does. It creates a copy. It creates a copy of the current version of what your master branch looks like. And typically these are done to create new features, right? That way we don't mess with the original and possibly break it or put it to a state that it is not working as intended. You then work on this new feature, and once it's ready to be implemented into our actual program, we then do what we call merging and merge it into our main branch. Well, how do we do that? Well, first and foremost, we're going to want to create a new branch. And to create it, we're going to use this syntax. Or we're going to check out, almost like checking out a book, right? We're going to say git checkout -b for branch, and then the name of the branch, right? This is going to create a new branch where you can make changes without affecting the rest of your code. So let's do that. Before you ever start a new branch, the first thing you want to do is you want to make sure that your project on your computer has the most updated version from GitHub, right? What's going to happen is you're going to be working with other people. You're going to be collaborating with other developers, and they're going to be working on features too, right? Something completely different from your task. And what might end up happening is they start messing around with a bunch of folders or files that they shouldn't be messing with, but they end up doing it. Or if there's a feature that depends on other features, and you move ahead with your work without ensuring that you have the most updated version, when you go to try to merge your feature with the main branch, you're going to find that the version that the master branch is in now is completely different than the version that you started off with, right? So to make sure that you don't start off already on a bad foot, you want to use the git pull command. And it's not going to do anything here because we have the most updated version. We just directly cloned it. And as you see here, I get a message that says already up to date. So what that tells me that I'm up to date. Usually you want to do something like git pull origin main. And notice it's going to try to fetch from the main branch, and it says it's already up to date, right? But you want to do something like this to ensure that what you're working with is the most latest version of the project, right? And now that we have confirmed that, the next step is to actually create that branch, right? So we are going to use that command git checkout. I'm going to call it -b, and I'm going to say new feature. I'll just use this new feature. And then get the response, switch to a new branch, new feature. Well, once again, just to make sure it's actually working correctly, and just to visually show you, I'm gonna call the command git branch, and I now see all the branches of my project, and I have main and new feature. Here's a question for you guys. What is it gonna look like on GitHub? Any guesses?
Is it even going to be on your GitHub?
It's not. Absolutely not. Once again, your local Gits and your remote repository are two different things. So although I created a branch on my Git, on my local Git, it doesn't populate yet on GitHub. If I come here, where do you check your branches? It's going to be right here. You probably already noticed it. Notice here that it tells you how many branches you have. I only have one. And if I want to look at the branches, I can press down on this drop down button, and it should show me the branches I have, right? Let me refresh my page just to show you. Once again, I refresh it to make sure it's actually up to date. Nothing's here, right? So although I created a branch on my local repository, that branch is non-existent to whatever GitHub is tracking. It doesn't know it exists yet. And that's important to know. Once again, Git and GitHub, two different things, right? They are on two different timelines. So now that I am on this new feature, I'm going to create a new file. And I'm going to call it new feature.js. New feature.js. I created this feature once I switched over to my branch, right? And that's another thing. When you start working with your project, you do not want to be working on your main branch. I mentioned it earlier. It's bad practice, right? But what's the point of GitHub if you're just going to be working directly off your main branch? You end up just messing up the only copy of your project. So you want to ensure that you create a new branch and you work off of that branch, right? So before you start adding things to whatever main has, you want to make sure that you are on a different branch so you can actually make some progress. Let's say I've been coding for 2 days or a day, all day, and I created a bunch of new features. That new feature is this, that JS file, the .js file I created. Sorry, tongue-tied. So I have this new feature. Now what do? Well, I'm gonna go ahead. I'm gonna say git add. And now I can run git status to see if it's in the staging area. And notice that in the staging area, I have added the new feature.js file. I am ready to commit it. So I'm gonna say git commit. This is my second commit. It commits it, and then I'm ready to push it. Git push. And notice I'm gonna get something here. The current branch new feature has no upstream branch, right? To push the current branch and set the remote as upstream, use the following command. What do you think this is asking for me? Correct, right? It's trying to connect it to GitHub. As of right now, it only exists in my local Git, so it doesn't know what to do on GitHub. So it even gave me the code I needed to connect it to my GitHub. So I'm gonna say git push. I'm gonna say set upstream. Where do I want to set it? To the origin, right? And then from there, you specify what you want to call this branch on GitHub, right? I want to call it pretty much the same thing that the branch down here is called, so I know which one it relates to. So I'm gonna say new feature. And then it goes through the same process. It now creates a new branch, right? And it's connected from new feature to new feature because they're named the same thing. And then it tells you branch new feature set up to track at the origin at new feature. Now we get this. This is different than what we got initially. Before, I was able to just refresh my page and it was here, right? But now we're getting something different, right? Why is this? Why do you think this is happening?
Because you are requesting to merge that branch into the main branch.
Close. You're on the right track. You're not requesting to merge it to the main branch yet. You're requesting to merge it into the new feature branch. Right. So, I pushed it up. Let me refresh this page.
Like an update or something.
So here's the new feature. I haven't requested yet, but it is here. Here's a new feature. Notice how I can branch between both of them. Here's main, and here's new feature. New feature has it, right? It exists. It's on my GitHub successfully, but it does not exist in my main branch. I have not asked it to merge it. But this is telling me that I had recent pushes, right? I did have recent pushes, and it was to the new feature branch. Now, if I want to merge it, then I will press compare and pull request, right? But Keegan, you're almost there. You're like 99% of the way there. But yeah, you're on the right track. It's telling me that I pushed up here, but to a different branch. Now I do have the option to merge it, right? But notice that main branch is its own thing, right? Here is the main branch, and I now have new feature branch populated. Notice it says 2 branches as well, and these are different, right? Here's going to tell you the latest commits, right? And the message that it came with. This is my second commit. It tells you how many commits it has, how recent, and it tells you when was the last time something was updated. These 2 files, the last time was 39 minutes ago. These are brand new. Here is my new feature.js, right? So here's the next part, and this kind of it's going to answer whoever's question. I forgot who it was, about how to prevent this to like just automatically send something you don't want to. I don't know who asked. What question was it? I think someone asked something very similar to this. What happens once you send it up? Did someone ask a while ago?
There was a question about what poll does, but I don't
Yeah.
remember what it was.
I can't remember off the top of my head. But as I mentioned during that time, there are safety measures, right? Just because you push, it doesn't automatically mean it's already in your main project. Sure, it's on GitHub, but it goes to a different parts, right? To that individual branch that you send it up to. The next step will be to compare and create a pull request. So let's click this and see what it's doing. All right, let's talk about this window right here. Once it takes me to a window where I can open up a pull request, and it's exactly what it's saying, right? You're trying to request to pull this new branch into a different branch. And I say a different branch because it doesn't necessarily mean the main branch. And you can fix that here, right? You can set up what branch you're trying to pull into what other branch. So here's the branches that I'm going to pull into, and this is what I'm pulling in, right? And you can tell by the arrow, pretty self-explanatory, right? I want to pull the new feature branch into the main branch, right? And then you can kind of go back and forth if you wanted to. So every time that you pull, you don't necessarily are going to just pull every single time to main, but a lot of times people do is they will create 2 different main branches. One is like your actual main branch that holds like this is like signing to prove nothing else touches this, and then you have a test development branch where it's pretty much the exact same copy as main, but you send it to like this test branch to make sure it works well with everything else, and then if it does, then you pull it into your main project, right? So sometimes you'll see that people create 2 different main branches, one for actual deployment purposes and one for like test development processes or purposes. All right, so we have 2 different ways of doing that. And then what GitHub will try to do from the start is going to kind of check if it's able to merge. Sometimes GitHub will be smart enough and it's able to identify conflicts of interest between both branches. And I say sometimes because this is not 100%, right? It would be nice if it caught every single error, but no one ever knows how something's going to work with other code unless you actually look at it, line by line. So that's something to keep in mind. So it tries to tell you if it's able to merge or not. And then it comes down here to the actual request itself, right? You're essentially putting like a request ticket, right? You add a title to this request, login feature, whatever kind of feature you're working on. And then you write description, work on the login feature and fixed the following. Let's see. Added a new button. Added functionality to the login button, whatever you want to be, just random jargon. You are able to put code in here too. If you wanted to, you can do something like Python, and you can put code in here. And then you want to see how it's going to look like. You press preview, and notice that it is able to put like little. It's gonna look very similar to how we had Jupyter notebooks. You can write little cell blocks, so you are able to type in manual code to specify like, something on the pull request. Um, so you can write it here and then preview how the message is going to look like. So if you want to put specific codes or how something should work, or whatever, you can add that here. It's not just Python. You essentially specify here. I can do HTML. Let's see, div. Yeah, so here's some HTML code. Very simple, nothing crazy. But you are able to add different code here. It is Markdown supported. Um, but this itself is it's a skill of its own. So you want to learn more about these, you have to do some little research or whatnot. But yeah, so here is where you would add your message, right? And then on top of that, what you're also able to do is add reviewers, right? Someone to review your pull request, right? You can assign this task to somebody else. I forgot the difference between both of these, if I'm being honest with you. I think reviewers can view it, but who actually takes care of it is the assignees. And then if you scroll down, you have to create pull requests, but the next important part really is this part, right? Where it tells you what was committed, how many files were changed, and then it shows you a history of it. Because this file has nothing, there is no code here. But you see here that I have like new feature.js. This is the section for the file itself. It's empty because there's no code. You'll see how it looks like once you actually have code in here. What it'll do is it'll have two sections, the before and the after on the right. It'll show it to you side by side what it used to be and what it is now. And then you would compare line by line, and it'll be color coded. It'll show you in red stuff that was deleted, and it will show you in green stuff that was inserted, and you can compare the before and after what it's going to look like. All right, so whenever someone does a pull request, they're essentially coming through here, reviewing your code, how many ever files you added, or however much code you changed, and they can see specifically what lines of code you changed, whether you deleted something or added something, right? So this is a very powerful tool. For the sake of time, let's go ahead and continue. I'm gonna go ahead and create this pull request. And then it brings you to the actual status of your pull request, right? So whoever comes to this pull request, they'll be presented with this. And then if you added restrictions to your project, like let's say on your project you set a restriction that it requires 2 people to sign off on a pull request, they will have something additional here asking them if they approve or not, and it will show who has to approve it. And then only then, once they approve it, you're able to merge it, right? Just because I don't have anybody else here, I can't really show you that right now. I'll find some pictures, but I can go ahead and I can pull the request, or let's say I'm not convinced that I want to pull it yet, I can add a comment. Hey, give me a second, my keyboard is giving me trouble. Hey, you need to fix line 150. Comment. Right, and here is like the conversation being had between you and whoever is your superior, your team leader, right? And then once stuff gets off, you come back here and you merge it, right? But let's go ahead and merge this pull request, and then you add some messages here to the actual merge, and you can confirm it. It says pull request successfully merged and closed. You're all set. The new feature branch can be safely deleted. And then, yeah, you can delete it as you want. I'm going to keep it there for now. But let's go ahead and go back to example repo. Here I am inside of my main branch. And notice that this branch now has the new feature.js. So it successfully merged those changes. Right? Cool. Any questions so far? All right. Let's say someone else just went through this process. They created a feature, but Dominic is working on something and he needs to pull the updated changes. How do I do that? Well, Dominic, let me go ahead and switch over to git checkout main. I'm going to switch over to my main branch. What do you notice about my main branch? It's not updated. I switch over to my main branch, but notice that the window I had opened of new feature, it's crossed out because it doesn't exist, right? On the left side, if I look at my repository, that new feature is not in my main branch, in my local repository. So although GitHub now successfully has an updated main branch with a new feature, the main branch I have on my computer isn't updated. Once again, two different things. You have to manually update these. So once again, I'm gonna say git pull origin main. And notice here that it says that it fast forwarded my branch. I have a new feature, one file change. I created this new file and it updated my directory on the left side. So although my main branch on GitHub was updated, the local main branch on my computer had not been updated. So everybody else who's also working on this project, if they want to make sure they have the most updated feature, they have to do a git pull, right? So it's very important that you're working on the most updated version and you keep up to date with your branches and your project. Before you start working, you typically want to ensure you do a git pull and you have the most updated version. Do I have any questions? All right. Time is 7:47. We're going to come back at 7:57 and go into our last hour of the night. I'll see you guys in a bit. I don't know if
Y'all
I
hear
was muted.
Roger?
There we go. My bad. I was muted. Thank you. Yeah, so the last thing we were going to cover, welcome back everybody. We're going to go ahead and continue on. But the last thing we had to cover was git merge. And this is exactly what it sounds like, right? You're able to just go ahead and merge one branch to another one if you wanted to from your command line. But the way that this would work is that you want to be on the branch that you want to add in your terminal, right? So if I was, and I can't really do because I already did this, I would have to go through the whole process to do the pull request. But essentially, say git branch, I would create another branch, git checkout -b second feature, right? And then once here, I would, add another file, make some changes, and I would make sure this is updated on GitHub. If I want to merge it into my main branch, I essentially could. I could say git merge, but if I was trying to go into my main branch, the way that you would do it is you want to switch over to the main branch. So I would say git checkout main, and then I would say git merge, and I would say second feature. And it's not going to work because they're both the same. But I am able to merge it from here. But the way you want it to work is you want to be in the branch that you want to update, right? You want to bring second feature inside of the one that you're in. Does that make sense? So just be careful when running this, when you do this, but it's going to give you the similar functionality as how we did on GitHub. So you are able to do that. All the code from your other branch will now be added to your main branch. Yeah, pretty straightforward. I'm going to do the same functionality as we did earlier, so I'm not going to run through this one. So I don't have to go through all those extra steps and waste time. But yeah, I did want to let you know that this is a possibility, but typically you want to go through the much more manual process. Now, the last thing about GitHub is really customizing your GitHub. This is not something you have to worry about right now. This is Guillermo. He was the original instructor for this course up to about almost 2 years ago. He handed over the torch to me, but when he created this, he added his own GitHub. I don't know if it still looks the same. We can probably check it out. I don't even know how to start. I've never looked for anybody's GitHub. I'm being honest with you. Let's see, Mr. I hope this works. Mr. GMO. Here it is. Oh my lord, he hasn't updated yet. Okay, he had this for years, but you're able to customize your GitHub to kind of showcase who you are, right? For those of you who are old as I am, if you remember the MySpace days, right, when someone would visit your MySpace and the music would start playing, and you had all these all this music and backgrounds and stuff going everywhere. You can do something fairly similar to that, right? This is what my GitHub looks like. It's nothing too crazy. I don't use it too often because I'm as an instructor. I'm not constantly just updating GitHub stuff. I'm usually teaching, so I don't have anything too crazy here for commits. But usually, you have a small introduction to yourself, what you do, what you're working on, how to reach you, so on and so forth. People like to display the stuff that they use to demonstrate, like, what they have in their tool belt and what they're familiar with. So you want to put like your languages, your frameworks, so on and so forth. Uh, you can put GitHub stats, how much of the stuff on your repository is consisted of what. So this is the most language that I use. So it takes these stats. These stats are from the code you have in your repository or stuff that you've committed and whatnot. Notice that I mostly use Python, a little bit of JavaScript. The GD script is from my game that I created. And then a little bit of CSS and HTML is very, 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 very little. 0.51% of what I've done on GitHub is HTML. But yeah, here's the languages. I have some stuff here to reach me, whether it's LinkedIn. I think this work. Oh, I gotta fix that. Let's check YouTube. This one should work. Hey, yeah, it takes these two guide application. I think that was like not the last one that just happened, but the one prior to that one. And then my Gmail. Typically, you have something similar to this. You probably see on your GitHub. I was able to customize it with this little snake game from the Nokia. For those of you who remember that, to kind of just customize it. When people look at your GitHub, they typically look for this right here, which shows your level of activity on GitHub. The more green you have here, like this, it just shows what days you were active. So these are weeks, and each one of these blocks represents a day. The greener the button is, the more you did on that specific day with GitHub, whether it's commits, whether it's pull requests, whether it's code reviews. It lights up, right? So there's some hardcore dudes that you can probably look through GitHub. The no lives, they'll have this, dark green all across the board. So this would typically give someone a good indication whether, how active are you with code. Because no one knows you're coding. You can say, yeah, I've been coding for the past 3 months. I'm like, all right, well, show me your GitHub. If you don't track it, no one knows that you've been doing it, right? It's almost like for those of you who have ever done community service hours for whatever reason, how do you know you're doing community service hours if if someone's not tracking, logging your hours or something like that. So kind of like that, you kind of have to track your progress through GitHub. So the more active you are on GitHub, the more of these boxes you have. And when you put your GitHub account on your resume, that's one of the little things they'll check, right? How can someone check how active you are or how good of a coder you are? We are going to tell you to put your projects on your resume. Ideally, you want to make sure your projects are deployed. Let me give you an example. If you worked at Google and you were interviewing thousands of people, like some of these companies, for example, the Accenture internship that I did, it had 16,000 applicants, right? 16,000 applicants. And they'll have teams to interview or to review resumes, right? But if they get to your resume and they're trying to see how good of a coder you are, you think they're going to go through where is it at? Let me see, my repositories. If I put this app, this is my personal project, my back end and front end. Here's some snapshots I took. It's nothing crazy. It was the first project I ever did. I didn't deploy it, so I took snapshots for the sake of ensuring that they can see it. It's a mess because I didn't add any HTML, CSS. But if you don't have something like this, or if it's not deployed, what do they have to go by? They would have to go through your actual app itself. Let me just show you how absurd this is. Let's go with library app. Not models. Let's go with, where's it at? My views. right? You think someone's gonna come through and go through all your code, read every single line, see how good of a coder you are? There's thousands of you guys applying, right? This is why I highly recommend, which is why they're going to recommend to you, deploy your website. But if they're not going to check through your files and look through your personal projects, what are they probably going to check? They're going to check your profile. You're going to send them a link to this, and they're going to come here and they're going to check your boxes. Has he been contributing to GitHub, right? And if this is black across the board, absolutely no way. So as you are working, this kind of goes back to answering Andy's question. What's going to make me stand out, or how they're going to know, if I'm a good applicant or whatever. This is one of them, a very small one, but this is one of them. They're going to check your GitHub. They're going to put your GitHub on your resume. Let me see if I have my GitHub on here. Not my GitHub, my resume. I am pretty open with my stuff, so I don't mind showing you guys. But where is? Let me show you what it's going to look like. Stand by. It's a little outdated. Right. But here is my project. This is kind of how your resume is going to look like, right? You put your technology certifications, your languages. I need to add C# in here. Your other tech skills that you may have. Your your experience. Yeah, this is very outdated. Whether you did internships, whether your jobs, but here is your projects, right? Your actual work, and you're gonna have a link like this. I just took down this website, so it's not going to send me there. Oh, it hurts me. I created a website to track my job applications because I was sick and tired of creating Excel spreadsheets to track which jobs I applied to. So I was like, I'm a developer, I can just make a website. So I did. But I no longer needed this because I was no longer applying to places, so I took it down. So it wasn't charging me no more. It was charging me like $10 a day. I'm sorry, not a day, a month. Like $10 to $13 a month, and I was like, no way. But people were using it, so I just took it down. Other whatever. But yeah, so you're gonna have something like that, right? Where you're going to put your projects here, and it takes you to there. But this isn't too helpful. So what you also have is going to be your GitHub on your resume to take you there. Right. So here it is. And then you can come down here and check your stuff out. Right. So make sure you guys actually have work on your GitHub and make it visually appealing, right? Make it stand out. So when they show up here, they can read easily who you are, and so on and so forth. So resource to complete this task, you can look into this. This is going to be on your on the curriculum. Let me go there right now. Repositories, curriculum. This is the wrong place. This is the curriculum for the full stack immersive program. Actually, let me show you in case you're interested. You guys will be seeing this. You guys will be. This is ordered by time, right? JavaScript, Python intro, object-oriented programming, AI, large learning models, full stack, front end, relational database management systems, Django, full stack deployment. So by the eighth or ninth week, you're already deploying a website, right? Or learning to, right? I said you go into personal projects, but it's kind of what you have to look forward to. But go back to foundation programming. You guys can definitely go into the README and you can check out building out your GitHub profile, right? So you can check these out. There's a bunch of stuff on YouTube that you can look at too if you want to. That'll show you how to customize it. Here's some other examples of how your GitHub can look like. This is not very important right now, but as you get closer to graduation, invest an hour of your time on this. Kind of just make it stand out, talk about yourself, kind of promote yourself to other people. So once you start applying, you have something that's visually appealing and welcoming. Um, so people can see. Here's you can change the color of this, but here's somebody that's been working a lot. I forgot who this is. Oh, this is Guillermo's. Uh, this is his snapshot from when he was applying to jobs. He actually has a pretty cool story about this that he believes he got one of the jobs that he got because of this snapshot right here. Uh, his longest streak on GitHub. Um, how many contributions he had, right? So he firmly believes that one of the reasons that he got one of his jobs was because of this. So you can take his word for it. Um, but yeah, make sure you guys are active on GitHub and you're working on it, right? Which is why it's important to understand how to work with GitHub. The Git pair student practice, this one always goes bad. It's really annoying to do, so we're not going to do this one. If you want to do more practice, literally just walk through everything that we covered today, right? Create a project, connect it, make some changes, make a pull request, so on and so forth. Yeah, it's as simple as that. Just get somewhat comfortable. You don't have to be a subject matter expert at all right now. Even myself, after a while, me not working with GitHub, when I have to go work at it, I have to kind of look things up here and there, and that's okay. But what's going to help you is that you already have experience with it, or you've been exposed to it, and now you can do a little bit better in the future. Does anybody have any questions about Git or GitHub? Anything that we have covered at all? All right. Let's go ahead and jump to the next part of today's class, which is how the internet works in HTML. All right, how the internet works. I don't know every single individual specific part from start to finish, if I'm being completely honest with you, but I know the general concept of it, and we're going to talk about that. All right, what is the internet? Who can give me their definition of what the internet is? Nobody? Well, at its lowest level, it is a bunch of wires all over the world, right? It is a bunch of wires connecting servers to each other, right? The internet, we like to think is like just flying in the air. It's a bunch of wires, right? And here's a nice little map of how it's working. But these wires, they essentially break down information and send them from one place to another in small little bytes, and then put them together on another part of the world. And it's just a bunch of servers talking to other servers, a bunch of computers in somebody's attic, right? Interconnected. Right? The internet is not magic. It is a bunch of wires. The browser. What is the browser? The term I'm looking for. What is a browser and what is it doing? What's up, Keegan?
Search engine.
Yeah, it can be a search engine. Absolutely.
Would
The
you
search
say
engine.
more of an interface between like changing from HTML to actual like user interface, so that way you can actually see what it is, graphical user interface?
Yeah, that's exactly what I was looking for. It's essentially an interface, right? A GUI, a graphical user interface, right? To display to you your websites. It's built off HTML, CSS, and JavaScript. But at its core, it's essentially just a GUI, right? It's a storefront to everything else. It's a pretty nice little GUI that allows you to manipulate web pages. The browser makes what we call requests, right? There's a couple of terms we're going to be using. One of them is going to be the client and the server, right? The client is essentially your computer, right? On your computer, you have a browser, whether it's at Instagram.com, whether it's Facebook, whatever website you're using, right? Your client is utilizing this browser, this GUI. And when you do something like, for example, log in, when you go ahead and go to a web page on this browser that takes in something like your username and email, it's going to put in what we call a request, right? This request is essentially kind of what it as the name implies, it's pretty much a request ticket with your information, right? It has a lot of information. What really matters to you guys, it'll have like your credentials, right? Whether it's your email, your username, it's gonna have your password, right? It's gonna have like your data. If you're trying to put in a request to update your profile picture, it would have like the image you're trying to update. If you're trying to update your name, you're gonna have like the name inside this request. It's going to take this information, right? This request is going to go to a server somewhere in somebody's basement or attic, right? Maybe in the other side of the world. And it's going to take the information that it got from this request. It's going to read through it. It's going to parse for specific things, right? And we're going to learn more about it once you guys get into the immersive program. But it's going to make sure that one, it's going to check what you're asking for. And it's going to, two, more importantly, make sure that the person who's asking for this information has access to this information. Should you be allowed to even have the information you're asking for, right? And this request will have these credentials. It'll verify you, all right, you're good, you're not good, and so on and so forth. If it checks you out, it's going to go to this request and look for the thing that you asked for initially, whether it's for an image, whether it's for to update something, to delete something. It's going to take your request and then it's going to do it. Finally, it's going to respond to you with, as the word implies, a response. This response typically is some kind of message, right? This response is either going to include the item that you asked for. If you go to Google and you type in cat memes, the response would include this cat meme, right? The image of the that you requested. If you decide to log in, right, the request you put in is to log in. The response is going to be either your actual information, if you got accepted, so it'll give you your information as well as a response code, right? And I'm sure you've seen this before, HTTP 404 not found, right? You might get a response like that, or you might get a response of 200, which means okay. You don't visually see the response, but in your browser, I'll show you how it looks like. So this response will return to you, to your client, with the information that you requested, as well with a message, whether it was okay, whether it was something was deleted, whether it couldn't find it, or whether you didn't have permission to do what you asked for it to do. In a nutshell, everything that I just mentioned is you here on your computer, clicking and clacking away at your browser. You request pictures of cats with funny hats. You type that into your browser. Your browser is going to take the information that you gave it and it's going to put it in a HTTP request. It's going to send it out through these wires that we mentioned to some server. The server is going to get hard to work, taking your request with the credentials that you gave it, as well as the request that you wanted, like the picture. Is to see if you should be having information or not. If it checks you out and you are approved, it's going to grab the information and it's going to send it back to you in the form of an HTTP response. Once it gets to your browser is going to receive this information. It's going to essentially decipher it and get you that picture of your nice little cat picture with a cowboy hat, and it'll present to you on your browser, and therefore you're happy. Right. So in a nutshell, from start to finish, this is kind of how it looks like. Right. There's not a magic wizard inside your computer giving you these cat memes. I went back. My bad. So what does the server do? It's going to return to you the contents of what you're asking for, and it's going to present it to you using three different things. HTML, CSS, and JavaScript. And this image does a really good way to present it to you in a way that makes sense, right? HTML is essentially the skeleton of our web pages, right? This is what holds it together. It gives it structure. The CSS is the outer appearance, right? The skin of the human being, the clothes they're wearing, their hair, right? What gives it that visual appealing look, that is CSS. Could you have a fully functional website that works well with no CSS? Absolutely, but it's going to look horrible, right? What really matters is going to come down to the HTML and the functionality, which is going to be the JavaScript, right? The JavaScript is what makes things happen. Why am I learning JavaScript, Roger? So you can manipulate stuff with your code. So you can tell your application how to do things. When you press on this button, slideshow, it's going to do something. How this works is coded in JavaScript. If I remember correctly, somewhere around 80% of any web pages out right now are coded in JavaScript. Right? So the functionality, right? The way the arms move, the head, the legs, the ability to run and breathe, that is functionality. How a web page goes from one page to another, how it's able to go and send a request to a server, that is all handled by JavaScript. Let's look at it real quick. In my browser, whatever browser you guys are in, if you are in a web page, what you're going to do is going to right click and you're going to get these options and you're going to look for the word inspect. Now, before we do this, I recommend for all of you guys to be on on the Chrome browser. Chrome has some dev tools that are very helpful. For your immersive program, I recommend for most of you guys to have Chrome. Will other ones work? Sure. I know Scott here uses what DuckDuckGo. I don't know how that's gonna work. I've never used it, but ideally you want to have Chrome. Let's just go to Google for now. I'm gonna look for a random web page. Someone give me a topic. Awesome, thank you. Weather. Use precise location. Surprise, I'm in Austin. Give me a second. Updating my location. All right, I don't care. Let's go ahead, open up the weather.com app. Inside this weather.com app, I'm going to do the following, and it's going to be to right click the web page, and I'm going to press inspect. What inspect is going to do, it's going to open up my dev tools. Right, you should be presented with something very similar to this. This is the elements that make up this web page. This is literally the HTML document that was used to create this web page. And as you notice, as I hover through this entire HTML element page, it's highlighting certain aspects of the web page. If I wanted to move my mouse over a specific object and see what it is, I can do that. At the top left of this inspect tool, there is what looks like a dotted square with an arrow pointing at it. I'm going to press this, and it's going to allow me to hover different components on my browser. And I'm going to scroll down. I'm going to pick something randomly, like this box here that says trending. When I hover over it, notice that's going to show me on the elements page on the right side what piece of HTML text is making up this box I'm hovering over. I'm gonna click it so I can kind of come over to the right. And it is a type section, and we're gonna talk about all these types. So don't fret if you're confused on what this means. But there's a couple things in here. Classes. Let's hover over. I'm gonna hover over the header here, the trending header. I'm gonna click it. I highlighted the trending, right? The word trending. Notice here that this element is an H2 element, and here I see the word that's actually within this element. It's trending. I can ideally actually manipulate this here, I took control. And I can change what's appearing on my webpage. Did I just hack this webpage?
No.
No, I
Hell
didn't.
yeah, you did.
No, I didn't. I like the enthusiasm. No, I did not. Uh, this is these are just dev tools. It allows you to kind of manipulate the web pages that you use. Although I changed it here, and this will be called kind of I don't want to call it a DOM, but it's a version of your dev tools that help you manipulate the DOM. But and we'll talk about what that is in a little bit. But these are just dev tools that allow you to manipulate different key components of the web page. You can kind of go through here, but I just want to show you how this text that's consistent that's within this H2 tag, it makes up this box, right? So everything within here is how this web page is structured. This is the skeleton, right? That's holding it together. Keep pay good attention to how all this is nested. There's a method to all this madness to really understand where things go, right? Which is why it's very important to pay attention to where things are indented in your code. And we'll talk more about this as we start working with HTML. I have a question, Daniel.
Yeah, well, I was going to say is that under the console, you can actually manipulate the website a little bit, can't you? Like to sometimes reveal like hidden features and like take off restrictions maybe the website has under the console. If you put in um, code. Do you know what I'm talking about?
I do know, and the console is another version of how your terminal looks, and we could definitely get to these in a little bit. There's a lot of stuff going on here, as you may see, but we will be using the console to do stuff like that here shortly, either today or tomorrow. But yes, you are right. There's a lot of things that we can mess around here with these dev tools that are going to allow us to help developing our web pages a lot easier. And there's a lot of stuff that's being loaded here. Uh, Usually error messages that are happening with the website. As you can see, there's a lot of error messages. But the console is very similar to your terminal on VS Code. You know how you guys use the print statement or console.log and it's printing out on the terminal. The console has a very similar functionality, right? This is where you're going to see your error messages. Or if you use console.log on your JavaScript, this is where you're going to see it. But yeah,
I've actually taken off restrictions that like a website had by going into the console. I've actually taken off restrictions that some websites had.
I'm not too knowledgeable of messing around with web pages like that. That sounds like a cool little hobby, Daniel. With one of these days, definitely show me the stuff that you've done. I'm really interested.
There is actually for these Army structured development courses. Not that you should do this, but if you hate doing the courses, there are web commands commands that you can plug into the developer tools that will essentially
Say the course is completed.
say the course is completed, so you don't have to spend however many hours doing the structured development courses. Not that I condone that. That's not okay. I'm just saying it's a thing you can do.
Yeah, I saw it happening when I was going to a BOC, the basic leadership course for sergeant in the army. I saw a bunch of people in our course trying to knock out a bunch of these courses doing something very similar to that. Justin is correct. That is something you can do. I'm not too knowledgeable in doing stuff like that because I'm a good boy, so I don't know. But yeah, but essentially, this page right here, the inspect tool, allows you to see the HTML structure of a web page on top of other stuff, right? The next thing I want to show you is going to be the network, I think. Yeah, I'm pretty sure it's a network. Here you can see different things that are happening, and I want to show you something specifically, like pressing the Today tab. Notice it loaded a bunch of stuff. This is a little overwhelming. I wish I still had my web page up. I had it for the last class. So I was able to show them different requests that you can make, and you can see how that worked. But this is a little overwhelming to kind of show you, unfortunately. Let's see. Maybe I can. Yeah, here we go. I can kind of restrict them, but these are stuff like requests that are being made. To specific URLs. Notice the status. There's a tool for the type of request it was. It's a fetch request, and we're gonna talk a lot more about these as we go into APIs and how to do this for a web page. We will be able to create a web page here in Foundation Programming where we talk with an API and make a request similar to this, so we can get a picture on our page from a third-party API. So we'll be working with all this. So you guys have a lot to look forward to. But here's where you will see the network. Um, and there's a couple other stuff that are going to be. Oh, I think it just crashed. Stand by.
It's because they detected you hacking their webpage and they were like, "Not today, Roger."
That's probably what it was. Yeah.
You went into that console section. Not good. That was the
I'm trying to open it back up, guys. Give me a second. Unfortunately, give me a second. I got a bunch of work stuff that I don't want to have on here. Okay, there we go. But yeah, I just wanted to show you guys those dev tools and how they work. And they're going to come into play. This inspect tool, we're going to be using this a lot during FOP, and especially in the immersive program. We're going to be using this a lot. Especially when you start working on personal projects, if you're building your own application, this is going to be crucial to your development. There's a couple other stuff, right? If you go to application, you can see stuff like cookies, right? If you're wondering, like, what cookies are, it's like history of what you do on your browser, places you've looked at. We have stuff like local storage, which we'll talk about while we're in this class of how we can use local storage to keep track of variables through pages. But yeah, we have a bunch of different stuff here available to us. And the last thing I want to show you guys is going to be this icon right here. Next to elements, you'll see it looks like a laptop and a cell phone. And what it's going to do for you is going to allow you to toggle different devices. So when working with your dev tools, you're actually able to change the screen you're working with to mimic a certain device, right? So if you want to make your website responsive and work with stuff like the iPhone 14 Pro Max, you can see. Let me remove this ad real quick. There we go. So this is how this website would appear if I was on an iPhone 14 Pro Max, if I was on a Surface Pro 7, Galaxy Z Fold. So you can check the responsiveness of your website, and as you can already see, this website is garbage on a cell phone. iPhone SE, not the best appearing website. They should probably work on the responsiveness for mobile devices. This is going to be very important, especially if you're actually trying to build a website that you're trying to maintain and kind of have traffic in, people visit your website to do different things. Because when someone sends you a website or tells you to check something out, what's the first thing you do? You pull up your phone. You don't run to your computer and check a website out. Almost every single person nowadays has their phone at their disposal, and if they want to check your website out, they're probably going to check their phone first. So when developing stuff, it's important that you are able to create something that's responsive not only on a desktop application, a laptop, but also on a phone, right? So just something to annotate. Any questions here? All right. So the golden rule for your folder structure is the separation of concerns, right? Here we see the common folder structure of what your front end project is going to be. For those of you who are fairly new to like this terminology, who can give me an example in their own words? What is the front end and what is the back end? This is an interview question I was asked when I was first starting off. Can you explain to me what the front end or the back end is? Anybody?
The front end is your web page and the functionality, like the login, the buttons that you can click, the videos that you see, all the design, all of that. The back end is taking the information plugged into your front end, storing the data like say Google Docs. It's keeping track of the people logged in, their files, and constantly communicating with the databases.
Yeah, that's awesome. Yeah, that's a pretty good example, right? The front end is, I like to call it the storefront, right? So whenever you go to a store, a restaurant, the front end is what you see, right? That's the outside appearance, that's the tables, the chairs, or that's what you visually see, right? That is what provides that user experience, right? It's the ambience of the place, right? In the website, it's how visually appealing it may look. It's also how stuff works in regards to the buttons, right? Changing from web pages to web pages, right? That is your front end. And your back end is like the kitchen, right? That's what actually is doing all the actual work in the back, doing the cooking, or in this sense, handling the data, right? So whenever someone logs in, the front end collects the information and sends it to the back, right? The back end takes your username, your email, they look through the database, they grab your information, and this is what handles all these requests that are coming in and giving back to the front end the information that you requested. All right, so both of them are very important. But yeah, that's kind of the front end. And then the front end, when working with the front end, there's well, honestly, for all of these, we have a specific folder structure, but uniquely with the front end is we like to keep everything separated, right? And we have here, as you see, we have the main folder, right? This is the main directory. And within this main directory, we have 3 different files. We have index.html, style.css, and app.js, right? All 3 of the different files are different types of files. One is strictly HTML, the other is CSS, and one is straight JavaScript. Why is structuring your folder like this important? Any guesses? Well, as the name implies, you want to separate the work, right? Separate the jobs of your different files. Let's say you wanted to update a button, right? The buttons for all login buttons across your page, or logout buttons across your page. And if you did the CSS within your file, and you had CSS, HTML, and JavaScript all in one file, this file will be 300, 500 lines of code to update if you wanted to change your periods, right? Let's say it's whether it's Pride Month, it's Black History Month, whether it's whatever it be, you want to change your periods, whether it's like Cinco de Mayo, whether it's Christmas, and you want to change the appearance of your webpage to go with a holiday, and you're going to be updating your webpage pretty easily. It can be very conflicting when you're updating the appearance of your webpage every other month, and you're having to navigate through multiple lines of code, right? You're trying to separate the actual functionality away from the CSS, and it can be really difficult to update your web page effectively. So we typically want to ensure that we separate whatever we are doing into their own individual web pages. So if we ever have to do it like just styling, we don't even touch the JavaScript, we don't touch the HTML, and we can update our web page as intended, right? Same thing with the functionality. There's no reason why I need to be parsing through CSS if I'm just looking for specific functions. So we want to separate the responsibilities of our web page to their own individual page, limiting what can go wrong or breaking anything else, right? It makes updating and scaling your application a lot easier. The syntax, HTML syntax, right? You guys should be familiar with the term syntax up to this point. Syntax is just a fancy word for grammar, right? When learning the English language or any other language, you tend to learn the grammar, right? Proper grammar, what nouns are, what verbs are, adjectives, the structure of a sentence. What happens if you use the word "and" in a sentence? Having a comma, stuff like that. Showing possession. That is what we call syntax. right? The syntax for HTML is significantly different than what you are used to if you've been coding in JavaScript or in Python. For those of you who have been working on the pre-work, is there work for you guys to do free code camp with HTML? Is that still a thing? Okay. Keegan nodded. Yeah, so for I'm assuming most of you guys already started kind of working on this and dabbling in some HTML, right? In HTML, we use we work with tags, right? Every piece of content within the file must be wrapped in tags, right? Whether it is a header, my bad. Whether it's a paragraph, whether it's a section, an image, an input tag, all of these are individual tags. There's going to be some exceptions for certain ones, so just pay attention. The common tag, the common structure of a tag is you're going to have an opening tag and a closing tag, right? Within the opening and the closing tag is where you're going to actually add the content that's going to go into this tag. So if you had a paragraph, like we have here, if you wanted to create a paragraph in HTML, you have to have a paragraph opening tag and a paragraph closing tag, right? We see something here that's a little out of scope for a little bit, which is class. Don't worry too much about it. We'll get to it in a little bit. But in short, every tag needs to have an opening tag and a closing tag. How do you differentiate closing and opening tags? That's going to be by the /, right? Notice that the closing tag here has a / before the P. This tells your document that this is supposed to be a closing tag, right? And you're going to see that some tags are a little bit different. Some tags don't have a closing tag with /, and we'll get to those in a little bit. But for the most part, everything works with tags. You have the opening and the closing tag. The content that goes in this tag will be between both the opening and closing. And then you're also going to see something like this where you have class, where you're able to give attributes to a tag, right? Think of it kind of, it's not the same, but it's fairly similar to a function, right? You're able to give it certain parameters or attributes, right? Or arguments. You're able to pass in things like that. You could do something similar like that to tags, but they're not the same thing. I just want to make sure I clarify that. But the same way you're able to do stuff like that, you can do that in a tag and pass in certain attributes. Typically, these attributes are classes, IDs. You might give them CSS here. You might actually want to pass in certain variables, but that will come later with React. But yeah, you're able to do all that within the opening tag. They're essentially attributes or properties, right? Every tag, for the most part, is going to have a reason for it. If you're going to create a paragraph, you want to use a paragraph tag. If you're using, like, if you're trying to create the title of your homepage, you're going to use a header 1 tag, right? There's header tags and there's different levels of them. I think they go from H1 to H6. As the number increases, the header gets smaller. But you're going to have something very similar to that. Before I continue, if you guys want to know or have something structured to read over, look over lesson 2. I think I have intro to HTML. You should have README HTML. Here we go. I break down in the README key concepts, which is the element, right? The building block of HTML, defined using tags, right? You have the tag itself, which is keywords surrounded by angle brackets. The attribute, as you just saw, additional information about the element, which is like, for example, the class. And then we have some other key concepts that you have to keep in mind, which is going to be the hierarchy, right? What tags follow what order and what trumps what. Here is a very, very basic structure of an HTML document, right? An HTML document starts with this doc type tag. It is a declaration. It is declaring that everything within this document is going to be HTML, It requires this, right? Your browser uses this to determine what type of code it's working with. So every HTML file is going to start with the doc type declaration. Keep that in mind. All right, so this tag declares a document that it's going to be an HTML5 document. The 5 is just the version of HTML that we are on, HTML5. Right, this is the basic structure of every HTML document, right? The next part of this document is going to be the individual HTML tag itself. Notice there are two different things. One is the declaration saying that this is an HTML document, and next is the actual HTML tag itself, right? This is saying that everything within this tag is gonna be HTML. Make sense so far? This is your root element. Now, the next part is the two other sections to your structure. One is gonna be the head, and the next one is the body. The head contains your metadata, right? It has all the important information, or I guess the settings of how your document should look like, right? What type of fonts you may have, right? What the tab should say, right? This right here, the fact that this says FOP/lesson2, you can control that by setting something here in the head, right? This is, as you see here, title. Page title, that's what this is. That is the page title. So you set that in the header, right? Additionally, you're gonna put what type of text you're using, what type of applications it's going to be running on. This is where you do all of that. When you connect JavaScript to your document, this is where it's going to connect. When you connect CSS, this is where it's going to connect. All that is going to go into the header. We're going to talk more about this in depth later on. And then finally, the fourth part to your basic structure of an HTML document is going to be the body. This is where you actually put the meat and potatoes of your web page, right? This is where you put the title, where it's, you have like, welcome to my website, whatever. If it's Facebook, this is where you put Facebook. And then following that, you put the contents, right? Whether it's a paragraph, so on and so forth. Any questions so far? All right, we're not going to get through too much, so we're going to talk about creating this basic HTML document, and we're going to stop there. Let me go ahead and go into the curriculum. CD, Platoon, FP, summer code, lesson 01. I want you guys to open up your curriculum to lesson 01. We're finally going to start getting into actual work with our curriculum, which is awesome. Unfortunately, we don't have too much time for today, but I'll get you guys started. Okay. All right. In here, get paired. Oh, not lesson 1. My apologies. I misspoke. I want you to do lesson 2. I drove you astray. Lesson 2. This should be how the internet works in HTML. Right on. Okay. Inside here, you're going to create a new file. Actually, let's call it a new folder. Create a new folder. And this is going to be HTML demo. Inside of this new file, you are going to create a new folder. I'm sorry, a little bit I misspoke. Inside of this new folder, you're going to create a new file. So you're going to go into the HTML demo, and I want you to create a new file. It's going to be called main.html. Main.html. This is going to be your very first HTML document you guys are going to be working with. Now, before we continue, there's something that I require you guys to do, and that's going to be installing an extension. So once you got up to this point, what you're going to do is you're going to navigate to the left side of your VS Code, And where you see this Tetris blocks, you're going to click that. This is your extensions market. In here, I need you guys to find live server. Oh no, it's not gonna work. Hold on, let me see installing. I have to install it in Ubuntu. Hopefully it works. This is the first time I run this on my computer because this is a new computer, so I don't know if it's gonna work well. But we'll see. But you want to install live server. Another one you're gonna want to install later, which doesn't really matter right now, is gonna be the prettier, the code formatter. This is going to allow your code to look prettier, and there's going to be some other extensions that I'll give you tomorrow that you're going to want to install. But for right now, what you need to get working is going to be live server. And what this is going to allow you to do is going to allow you to open up your HTML document in your browser so you can see in real time the changes of your code. Once you have that installed, I want you to navigate back to your main.html. Now, I'm assuming we're all there. We might go a little over time. If you guys need to leave at 9 p.m. short, 9 p.m. sharp, then go right ahead. I don't want to hold you guys back. But if not, I'm gonna try to make sure I at least get to this little part, and then we'll call it. But I'm assuming we're all there. So once you're here, all you're going to do is I want you to press the type in an exclamation mark and nothing else. Don't move your mouse. Don't click nothing else. What you're going to see is a drop-down menu. You're going to have an exclamation mark and 3 exclamation marks. What you're going to do is on the 1 exclamation mark, you're going to press enter. What this is going to do for you is it's going to create what we call a boilerplate for a very basic HTML document. Now, can you hard code this? Absolutely. But I'm just showing you a nice little shortcut because none of this really changes ever unless you have some specific things you want to change. But this is the most basic standard HTML document. Notice that it has your doc type. It has the HTML tag enclosing everything. And then within here, we have the body and also the head. This is the most basic document. Make sure you press Control S to save your document because sometimes your VS Code isn't set up to autosave as you make things or you make changes to your document. You're going to want to change that in the future, but right now, just press Control S to make sure it's saved. And if you are at this point, what you are going to do is you're going to right-click your web page. And after you have Live Server installed, you should now have this section here where it says Open with Live Server. You're going to click that. I'm getting some messages here that says your application is running on port 5500 is available, and it tells me open in browser. I'm going to click yes. And unfortunately, I have to fix my live server. This is not correct. We'll get to this later. For those of you who have this issue, I have to fix it for mine. And then once I fix it for mine, I'll show you how to fix it. But this should have opened up a white page, right? Unfortunately here, it's showing me the structure of my document. So I'm going to go ahead and I'm going to click HTML demo, which is where I was at. And then I'm going to click the main.html and it should take me there. But it should have taken me there already. But unfortunately, I had to click it directly. And it's just having to tweak the live server settings. But you should be in a location very similar to this. Live server is very tricky sometimes, so I know we're gonna have some issues with some people. Like, hey, my browser isn't opening up, nothing even shows, or when I do open it up, it shows me like my directories. I understand. We will handle those individually. I still gotta fix mine too, as you just saw. It happens when you first install it. It happened to me when I first did it in my last laptop. It's okay. We'll work through it. But at least I'm able to get here for now for this demonstration. Now, what I'm going to do is I'm going to separate these left and right so I can code on my left side and I can see what's happening on my right. And just to get something here on this page, inside of this HTML document, what I'm going to do is I'm going to type in an H1 tag, right? Notice it's going to try to autofill it for me. Just you can autofill it if you want. It has the opening tag and the closing tag, and I'm just going to type in hello. And if your live server isn't set up, it might not refresh it. You might have to refresh it manually, but you should have the hello pop up in real time as you code in your HTML document. You should be able to visually see what you are doing in your HTML document on your browser.
Okay, sorry, I might have missed it. How did you get to I guess the web page from VS Code?
Right.
Or how did you try to do it? Sorry.
Yeah, so you should be able to, let me go ahead and close this up. You need, first and foremost, every single one of you guys needs to install live server. This is what helps you launch that browser. It is made for that, right? So launch a development local server with live reload feature for static and dynamic pages. This extension is what allows you to do that. So once you have that installed, you're going to return to your HTML document. You're going to right-click your HTML document, and you should now have this option down here that says Open with Live Server. You're going to click this, and it's going to ask you if you want to open it up in your browser. Unfortunately, mine is not asking me anymore. That is very upsetting. Let me go ahead and try it again. All right, it's not working. Let me go ahead and stop it, and then I'm run it again. And there it goes. Now that I stopped it and I ran it again, it's now telling me it's running and I can open it in browser. I'm going to click open in browser and it's going to bring me here. Unfortunately, this should not give me this file path here. This should not show me any folders. This is incorrect. I need to tweak the settings for live server. But if you do get something similar that I got now, all you have to do is just go into directories where the HTML document's at and then click the document and you should bring you here. Does that answer your question, Dominic? Awesome. And unfortunately, that is everything we are going to be able to get through for today. I'm going to go ahead and stop the recording